In this video, we're going to be looking at the volume of a couple geometric figures. In particular, we're going to be looking at the rectangular solid, which is also slash cube. So a cube is a rectangular solid, and so that's why I'm putting those together. And then looking at the volume of a pyramid. But before we start with developing the formulas for these guys, I wanted to talk to you a little bit about what volume is and the unit of measurement for volume. Okay, going back to where we started by looking at the perimeter of a rectangle. Oops, missed. Let's try again. Looking at the perimeter. My rectangle side isn't very straight, so I guess it doesn't matter if I miss. So the idea there is that perimeter is a linear measurement. So what we would do is take a ruler and measure along the side there, figure out how the length of that side, length of the next side, and so on. So it's a linear measurement or one-dimensional measurement. And so the units are lengths. So 1 inch is a length, 2 inches a length, 1 foot is a length measurement. It's the distance along an edge or a curve. The next thing we did was we looked at area. And area was essentially figuring out if I chop this shape into a bunch of squares, somewhat squarish, then how many of those squares would it take to fill that shape up? And so there our unit of measurement was a square. Now it could be a square centimeter, a square inch, a square yard, but we're essentially taking squares and using them to tile in a two-dimensional shape. Because that's what we're doing when we're looking at area, is we're looking at two-dimensional measurement. So we have to have a two-dimensional unit of measurement in order to measure things. Now we're moving on to volume. And volume measures three-dimensional shape, or how much volume it takes to fill up a three-dimensional area. And this is incredibly challenging to show in a two-dimensional fashion. And so what we do is we kind of give the appearance of 3 dimensions on a two-dimensional plane by drawing perspective drawings. But for some people these are very hard to see as three-dimensional figures because they're not. But that's the idea, is to then fill the space up with stuff, with three-dimensional stuff. And so when we're talking about volume, we're talking about filling up a swimming pool or building a brick wall. It takes up three-dimensional space, and because of that, the unit of measurement needs to be three-dimensional. In other words, when we're talking about how much it takes to fill this up, we're going to be filling it up with little cubes. Now it could be a cubic inch, it could be a cubic centimeter, a cubic foot, and what that is let's say this is an inch on each side, an inch there, the depth is an inch, the height is an inch, and then we call this a cubic inch because it's an inch on each one of its sides in three-dimensional, and its length, its width, and its height. In those 3 dimensions, it's an inch on each side, so we call it an inch cubed or a cubic inch. It's a thing, it's the unit of measurement for three-dimensional space. There are some units of measurements like liters that are also for 3-dimension, where the fact that it's three-dimensional isn't embedded in the unit of measurement. It's not a cubic liter because liters are just liters, but we're still filling up space with those. So that's the idea of what the units are. Is there, like, if we're talking about a cubic inch, it's a bunch of little cubes that are an inch on each side. And so when we're talking about how many cubic inches something is, it's how many of those little bitty cubes it would take to fill the space up or to create that figure. So now that we see that, I'm going to clear the screen out and show you what it looks like to deal with cubes, like the volume broken into cubes. The best well-known object I know to talk about what's going on with volume is a Rubik's Cube, because a Rubik's Cube is one big cube that's made up of smaller cubes. Now, if you're like me and you've taken a Rubik's Cube or two apart, you know that on the very inside there's not little cubes. It's the mechanism that allows it to rotate. But for the sake of learning, we're going to pretend like the whole thing is cubes through and through. And so if I take this bottom layer here, then it's made up of cubes, and I'm going to draw that bottom layer over here. Alright, so to the best of my ability, I just drew that bottom layer, not to scale, but I just shaved it off like a layer on a cake. And then, so now we can see that that bottom layer is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes, just assembled together. Okay? Alright, similarly, we could say that each one of these layers is going to be another, like we could shave those off, and those could be 3 layers to our lovely Rubik's Cube wedding cake. Okay? So each one of those layers will be made up of 9 cubes. And we could number those out, like I said, or we could see that it's 3 cubes wide and 3 cubes deep, and 3 times 3 is 9, so that's a total of 9 cubes, and each one of them's like that. So if we add all those up, we would get 9 plus 9 plus 9, but, you know, multiplication's fast addition, so that's 3 9s, so that's 9 times 3. Okay, but remembering that that 9 originally came from my 3 by 3 layer, breaking that apart, I'm going to get 3 times 3 times 3. So essentially what we're doing there is taking a length of 3, a width of 3 on my Rubik's Cube, and a height of 3 on my Rubik's Cube, and multiply those all together, and I get the total number of cubes that are filling up my Rubik's Cube, which is 27 cubes. Now I haven't been using units here because I'm just doing visually, hey, it's a cube. If you could just call it a 27 cubes for your unit, because we don't know if they're cubic inches or cubic centimeters. A Rubik's Cube is neither of those. I think my guess would be they're about ½ an inch each. I don't know. Anyways, so that's the idea of finding the volume of these rectangular solids, is we're essentially just figuring out how many cubes it would take to make that rectangular solid, or to fill it up, if you think in terms of like an aquarium, how many rectangular solids it would take to fill it up. And that's going to amount to how many it is wide, long, and high, or its length, its width, and its height. And that's basically the formula for the volume of a rectangular solid. So the volume of a rectangular solid is its length times width times height, to determine how many total cubes it's taking to make our Rubik's Cubes. Now, here I did the example of a Rubik's Cube because it's a well-known rectangular solid, but it happens to be a cube itself. So the length, the width, and the height are all the same, and so then when you get this formula, sometimes people will say it's as s cubed, since they're all the same, but that's only with perfect cubes. With any rectangular solid, the length, the width, and the height can be different, and so you have to consider each one of them individually. Alright, so now that you can see what's happening with my Rubik's Cube wedding cake, we will switch to a rectangular solid that isn't equal on all sides. So we can do just a full-fledged example on that. Alright, so here we have a rectangular solid, and I was realizing as I cleared out my screen that I never really explained what a rectangular solid is. So a rectangular solid is a three-dimensional object where all the corners of it come to 90-degree angles. So, you know, stick of butter, Rubik's Cube, shoebox, all that kind of stuff. Those are rectangular solids, Kleenex box. any boxes, basically. It's a fancy math word for a box that is, you know, regular on our right angles on all the corners. So here we have a rectangular solid, and in order to determine the volume of it, we need some length. So I'm just going to make some stuff up here and say that this is 5 inches, this is 2 inches, and this is 1 inch, 1.5 inch. Let's throw some fractions in there, decimals in there for fun. Okay, so that's my length, my width, and my height, and that's what you need for a rectangular solid. So the idea there is if this is 2 inches high, then I'm going to cut this into 2 layers on my cake. If it's 5 inches wide, I'm going to slice it 5 times this way. Okay, 1.5 is a little weird because basically we would have a half cube in the back. And we'd have to put all those half cubes together to determine how many total cubes we'd have. Now that's if you weren't going to rely on arithmetic to figure it out, but that's to visually give you a sense of what we're figuring out here. Okay, so when we do the volume, we would get length of 5 inches times width of 1.5 inches times its height of 2 inches. Again, write those formulas out raw and think about what they mean as you write them, and that'll help you memorize them. So we have the volume equals 5 inches times 1.5 inches times 2 inches. And using the formula keeps you from having to count all those and glue partial cubes back together and so on. Alright, so 5 times 1.5 times 2 is 15, and then inch times inch times inch is inches to the third. So it's 15 cubic inches. So if you think of it conceptually, we have 10 of those along the front. Along the back, we have halves of 10, which is 5, so that's a total of 15 cubic inches. Alright, so hopefully that you're seeing how that works and why the formula is what the formula is for rectangular solids, and it's a straightforward calculation as long as you know how to put the numbers together. Now let's turn to the volume of a pyramid.